Good morning, students. So let's begin with today's topic, that is heat. So first, let us try to understand what is heat. So if we talk about heat, actually it's a form of energy. It's a form of energy, right? So energy means it has some ability to do your work. So example, if I talk of, then heat energy gets converted to mechanical energy. Okay, it gets converted to mechanical energy. So device that is implemented here is a heat engine. Okay. Okay. So I hope it is clear to you all. So this is a form of energy. Normally, this is an example I have taken in which it gets converted to mechanical energy, but also other forms of energy conversion is possible. All right. So let us now discuss one term that is known as temperature. One term known as temperature. So it is actually your degree of hotness or coldness of a body. Your degree of hotness or coldness of a body. Fine. So this temperature is measured in 5 different scales. We have 5 different scales: degree Celsius, Kelvin, degree Fahrenheit, degree Reaumur, and degree Fahrenheit. Alright, now let us see these 5 different scales and how can we convert one scale to other form. So we have here in total 5 scales. This is one scale we have. This is my second scale, third scale, okay, fourth scale, and fifth scale. So if I start with degree Celsius, then this is starting is my 0 degree Celsius. In between you have 100 divisions. Finally you have as 100 degree Celsius. Okay. In the second you have 32 degree Fahrenheit. In between there are 180 divisions, and it is 212 degree Fahrenheit. Okay. Here you have, say, Kelvin starts at 273.15 Kelvin. In between there are 100 divisions, and maximum you have is 373.15 Kelvin. And this you have your Reaumur is 0 degree Reaumur. In between you have 100 divisions, okay, and maximum you have is your 80-degree rearmor. And here you have 492-degree runtime. In between you have 180 divisions, maximum reading 672-degree runtime. So if I want to convert one form to another form, say C degree Celsius, I want to convert to different scales. So C minus lowest reading is 0 degree Celsius, so I'll take I will take here C minus 0 divided by 100 is equal to F minus 32 by 180 is equal to K minus 273.15, or simply 273. For calculation purpose it will be easy, so we take 273 divided by your 100 divisions, that is equal to say R minus 0 by 80 divisions is equal to Ra minus 492 by 180 divisions again. Okay, so this value is always equal to some kind of constant. So hope this is clear to you. Moving to the next term, let us understand what is known as specific heat. So actually specific heat means, say this is a body I am having whose mass is 1 unit. Okay, 1 unit can be maybe gram or kg or whatever it is you can take. Say temperature is also say 20 units. You can take this to be the degree Celsius or Kelvin or degree Fahrenheit, whatever you want. And I want to raise its temperature, say to, this is my T initial and T final, I want to make it to 21 units. So that can also be again in degree Celsius, Kelvin or degree Fahrenheit, but in this case both the units has to be same. And you can see that the rise is by 1 unit. Okay, rise is by 1 unit. So how this 1 unit rise will be there? I have to supply some heat. Okay, I have to supply some heat to this body, then only there will be rise in temperature. So how much heat I am supplying? So for example, I am taking 10 joules of heat. Fine. So 10 joules of heat is required for 1 unit of this substance to raise its temperature by 1 unit. So that is nothing but known as your specific heat. Okay. So that is the specific heat. Let me write down its formal definition. It is defined as the amount of heat required by a unit mass to raise its temperature by 1 unit. Okay, I hope it is clear to you all. Now let us understand what is known as your normal boiling point. Let me first write down its definition. It is defined as the boiling point of a liquid at 1 atmospheric pressure. Okay, or what 1 atm. So defined as the boiling point of a liquid. What is the boiling point? It is a particular temperature at which a liquid starts converting to vapor form. Starts converting to vapor form. Yes, vapor form from its liquid form. Okay, I hope it is clear. So with pressure has a great role in your boiling point. If you increase pressure, boiling point will also increase. So this is the concept that is used in a pressure cooker actually. Okay, you have here water, keep some vegetables here. When you supply heat, what will happen? This liquid molecules will start rising to its vapor form. This vapor will exert a pressure. Okay, so what will happen? Boiling point will increase. Boiling point will increase. Hope this is clear to you. Moving to the next is your melting point or normal melting point. So if I talk about normal melting point, then you can write it is the melting point of a substance at 1 atm or 1 atmospheric pressure. So what is the melting point? It is again a temperature at which a solid starts converting into its liquid form. Okay, so pressure also affects melting point. If you increase pressure, melting point will decrease. Okay, so moving to the next part, sublimation. It is a process in which solid gets converted into gas form without converting to liquid. Example: camphor, naphthalene, dry ice, etc. Okay, next we have is evaporation. Now what happens in boiling? This is water. I am supplying some kind of heat to this water. So in boiling, what happens? Entire molecules will start getting converted to vapor form. Okay, this will keep rising. Evaporation is actually surface phenomenon. Okay, it's a surface phenomenon. So on the surface, the liquid that we have, it will get converted to vapor form. It occurs only at the surface level. Okay, This is what is evaporation. We have different modes of heat transfer. Modes of conduction. So conduction, it is a mode of heat transfer in which particles vibrate about their mean position. Particles vibrate about their mean position. It takes place only in solids. I have an iron rod over here. Yeah, we do have an iron rod. I am hitting at this point, so this heat will be getting transmitted to the other end. So here the molecules will start vibrating about their mean position and energy transmission will take place. Okay, this is known as conduction. Second we have is convection. Convection, what happens is that heat transfer takes place by actual motion of molecules of fluids. Example can be liquid or gas. A liquid or gas. Because is there, I am having water molecules. I am applying some heat over here. These molecules on the bottom surface will get heated up faster. They will get heated up faster. Move to the surface, they will become lighter. Move to the surface. Surface particles will come to the bottom, get heated up and again move up. This is actual motion is taking place. So same thing is happening in gas as well. So this is what is convection. Of radiation. Here heat is transferred without the help of any medium, that is in vacuum. Okay. Example, earth gets heated up by radiation. Okay, so these are the three modes of heat transfer. Okay, so if we compare the different modes of heat transfer, so fastest is radiation, then we have convection, then we have conduction. Okay, so these are the three. This is the way in which heat is transferred. This is your radiation, then convection and conduction. This is the decreasing order of heat transfer. Then you have different types of systems. One is closed system, open system, isolated system. Closed system means only energy transfer occurs. Open system, energy plus mass transfer occurs. Isolated system, neither mass nor energy transfer occurs. Hope it is clear to you all. So let us now discuss about electricity and magnetism. So under electricity, let us see what is electricity. The flow of electrons constitute electric current. Okay, and one more point is that electric current flows opposite to the direction of electrons. Electric current flows opposite to the direction of electrons. Then next we have write down electric current uh, Good morning, Rashmita. Hope you are doing well in your studies. Electric current is denoted by capital I. SI unit is ampere, denoted by capital A. I is Q by T. This is coulomb per second ampere. Okay, coulomb per second, it is ampere. Electric current is a scalar quantity. Any doubt so far? Any doubt? Please ask me if you have any doubt.
आपके द्वारा रबड़ बनाई है या फिर आप लोगों को कहा कुछ पिछले दिन का कार्य जो टाइम है जो आप एक दूसरे के साथ रहकर उसे सिखाने के लिए आए हैं या फिर आप जन्मों जन्मों के पार्टनर हैं मीन्स लाइक तो पिछले जन्म से और जन्मों जन्मों से ही
ग्राम कोटा चिड्डी गया करे सारा बैंडविड्थ स्लो अच्छी है डाटा जो रेट ट्रांसफर होगा था स्लो रे ट्रांसफर है Okay, so let us continue now, students. Electric current we have studied till it is a scalar quantity. Fine. So now let us proceed to the next part. In this electricity, let us first understand a term called resistance. Okay. So resistance is actually opposition to the flow of electrons. Okay, opposition to the flow of electrons. So if I take a wire, this is a wire of any material. If I take it of any material, say electrons are flowing through this, which will constitute what? Electric current. Fine. So when it will constitute this electric current, what is going to happen? This material will also offer some kind of resistance or opposition. Resistance or opposition. Okay. So if I want to increase its opposition, I have to use a device called resistor, and this is the device. It looks somewhat like this. Alright, so how do we measure this resistance? Its SI unit is ohm. Okay, its SI unit is ohm. So we have a term called conductance, which is equal to the reciprocal of resistance. Alright, so if I write down this, so conductance unit will be, this is nothing but called mho. Okay, mho is the unit of conductance. So hope this is clear to you all. Proceeding to the next term, we have here resistivity. Now we write resistance is directly proportional to the length of the conductor, inversely proportional to the cross sectional area. This is a conductor, so length cross sectional area. So R is written as rho L by A. This is a constant and this is nothing but known as resistivity. So I can write rho as R into A by L. So this is ohm into meter square by meter. So this is equal to your ohm meter. Okay. So resistivity SI unit is ohm meter. Okay. So if I take, there is another term called conductivity. So conductivity is inversely proportional to resistivity. So it will be ohm inverse meter inverse. Sorry. Okay, this is ohm inverse meter inverse, or this is nothing but mohometer. Okay, mohometer. Hope it is clear to you all. Moving to the next part, power, or I can say this as electric power. How do we define this electric power? Hmm? Anybody? How do you define electric power? It is defined as the energy consumed by an electrical device per unit time. So this is an electric device consumes 100 joules per second, known as watt. This is equal to 100 watt. Okay, so how do we measure power? Written as V square I. Okay, this is power. So this is a electric wire and current I is passing. This will give rise to some heating effect. So H can be written as I square, written as I square RT, where T is the time for which current flows in a wire. Current flows in a wire. Fine, hope clear to you all. Okay, so going to the next, let us discuss resistors in series. Okay, so resistors in series. Resistors in series means current flowing is same. This is R1, this is R2. Current flowing is same. Then I can write here net resistance as R1 plus R2. So resistors in parallel. This is a resistor. This is another resistor. R1, R2. So here potential difference is same. That is, I can say here V1 and here V2. So V1 equal to V2. So 1 by R net is 1 by R2. Okay. So if it is clear to you all. ଯାଉଛି ରହୁଛି ଯାଉଛି ରହୁଛି
नहीं सी तो एक्चुअली नेट प्रॉब्लम स्टूडियो ठीक वो एटा में हमर नेट प्रॉब्लम अछि हमर चालू
अच्छा अच्छा
स्टूडियो मान ठीक
ओहो मुझे लिखी था जाना पड़ियो तो
हां
okay. Well students, now we're back with the connection. Okay, there's a lot of net issue, internet issue. Now we got connected. Okay, fine. So this is what is about your series and parallel I was talking about. Now let us understand some properties of fluids. Okay, in the properties of fluid, first we'll study is the pressure. Okay, so when we talk of pressure, so we write it as it is defined as the normal force acting per unit area. It is defined as the normal force acting per unit area. This is the force per unit area, or F stands for normal force. So SI unit is Newton per meter square or Pascal. Pascal. Second, related to this pressure, we have Pascal's law. It states that force, sorry, it states that pressure acting at a point in a container acting at a point on a container acting at a point on a liquid on a liquid enclosed in a container gets undiminishedly distributed in all directions. Then let us understand buoyancy force. I am taking a container, have some liquid in it, body is submerged. Weight will act in downward direction, same direction upward buoyancy force will act. Okay, so this is an upward force. Upward force acting on a body which is partially or fully submerged in a liquid. Okay, not liquid exactly, like this is in a fluid. Next we have Archimedes principle. It states that the buoyancy force acting on a the buoyancy force acting on a body is partially body in a partially or fully submerged body which is partially or fully submerged is equal to the weight of the body, sorry, is equal to the weight of the fluid displaced by it, is equal to the weight of the fluid displaced by it. Okay, so hope it is clear. Fine. So next we will be dealing with is viscosity. Yes, Gayatri, any doubt, or Rashmita, any doubt? No, okay, fine. Next, let us discuss viscosity. It is the opposition offered between the adjacent layers of a fluid. Alright, so that means, say this is a fluid that is flowing. So there are different layers of a fluid. These are the different layers. So each layer will try to offer some kind of frictional resistance to the above layer. Okay, so that is why the free flow is restricted. Alright, free flow of layers is restricted. It is restricted. Fine. So this is nothing but known as your viscosity. And SI unit is Poiseuille. Alright, so hope it is clear to you all. Next, let us discuss about Bernoulli's principle. It states that total energy of a flowing fluid remains conserved. Total energy of a flowing fluid remains conserved, that is P by rho g plus V square by 2g plus Z is constant. Example is lifting of aircraft. Okay, lifting of aircraft. This is an example. Let us deal something about atomic nuclear physics. Let's understand atom first. It is the fundamental particle of an element. Atom has electrons, protons, neutrons. Electrons are negatively charged, protons are positively charged. This is minus 1.6 10 power minus 19 coulomb plus 1.6 10 power minus 19 coulomb. So an atom is neutral in nature. Okay, protons, they do not have any charge. Electrons, discovered by J.J. Thomson. Protons by Rutherford. Neutrons, James Chadwick. Okay, so hope it is clear. Next, let us understand what is nuclear fission. This radioactive heavy nucleus splits into two or more lighter nuclei. Heavy nucleus, lighter nuclei plus energy. Now this energy is used for making your atom bomb or nuclear power plant. Or nuclear fission. Two lighter nuclei combine form a heavy nucleus. Okay. Two lighter nuclei combine to form heavy nucleus. Here this is happening in sun. Hydrogen and helium will have plus energy. So this is used for making hydrogen bomb. Used for making hydrogen bomb. Okay, and hydrogen bomb 1000 times stronger than atom bomb. Alright, so hope this is clear to you. Now let us discuss that. See, 92 uranium 235. This is a radioactive element. Radioactive element. Okay. What this element is used in your nuclear power plant to obtain electricity. Alright. So hope this is clear to you all. Uh, with this, we come to the end of this session.